So Unit 7 is actually entirely an algebra unit. So this is our extra unit that regular geometry does not have. This is more to set us up for Algebra 2. So if you're already taking Algebra 2, fantastic. This is probably all going to be review for you. That's awesome. Other people who are not taking Algebra 2, this is going to be a great way to kind of set us up. Get ready for that. I know it's still a semester away before you get to Algebra 2, but hopefully a nice break from some geometry stuff. So taking a look here at day 1, this is all a review day pretty much. We're going to be talking about function notation and solving by factoring. So function notation we've seen before. This is a fancy way for us to say y equals something. So instead of y equals, as we get higher into math classes, we like to use f of x as our notation. It's going to tell us the input of our function. It's going to tell us the output of our function. The x value inside these parentheses represents our input, aka the domain. F represents just literally the name of our equation. So this equation is named f. It's the most common one. It stands for function. You also see g a lot. You see h a lot. Give me any letter you want to. The rest of it is called the output, so the equation part of it, that's our output. I also just like to say that like this, let me choose purple. This whole thing right here is the output. So either side is the output. The thing in parentheses is the input. So f of x, when I see f parentheses x, that does not mean f times x, that means f of x. Pretty clear? So let's see how we use this. Here's my equation. It is called h of x. That's another name for a function. H of x equals x squared minus 3x plus 5. In letter A, it says find h of negative 3. It's giving me an x value. This thing in parentheses is our x. It is our input, which means I am literally going to take it and I am going to plug it in for the x's in my equation. A lot of us got this wrong. There's those last two problems on our test, if you remember what they were. A lot of us got them wrong, like 98% of us got them wrong, just because we did not plug things in parentheses. So we are going to make extra sure that when I say h of negative 3 and I start plugging things in, that I put this negative 3 in parentheses every single time I plug it in, because I got to remember that that negative goes with that 3. So negative 3 squared is 9, positive 9. Negative 3 times negative 3 is also a positive 9, plus 5. 18 plus 5 is 23. So I had an input. My x value was negative 3. My output, my y value was, 23. Questions on that? Pretty straightforward. I didn't do anything crazy. We've been doing that since Algebra 1. Now in the next one, I'm doing essentially the same thing, except we made the input something a little bit more complicated. My input is x plus 2. That means I'm going to plug in this entire thing into my 2x values. This one right here and this one right here. Nothing else changes other than I'm plugging in something a little bit weirder. So let's say h of x plus 2 equals, and again, here's where those parentheses are really important, x plus 2 quantity squared minus 3 times x plus 2 plus 5. Everybody good so far? Now when we start simplifying, I need us to all pay attention to this part. A lot of you, even though I'm saying this to you right now, are going to tell me that x plus 2 squared, I can take this 2, this exponent 2, and I can distribute it and say that that is x squared plus 4, x squared plus 4. We cannot do this. Draw yourself an angry face. Sad, bad, don't do it. X plus 2 quantity squared is the same thing as writing x plus 2 times x plus 2. That's what squaring something means, right? It's multiplying it to itself. So we actually have to expand this and distribute it. X times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. I can combine these like terms, and this is x squared plus 4x plus 4. So look at the difference here. We cannot distribute that squared because I will be missing the 4x term in the middle. So please, please, please star this. Whatever you need to do to remember, you need to expand and double distribute. The rest of the simplifying should be easy from this point. I'm going to do also distribute this negative 3 right here. Negative 3 times x is a negative 3x. Negative 3 times 2 is a negative 6. Drop down that plus 5. And then from here, I can just combine my like terms. I can combine the 4x and the negative 3x to get plus 1x. And then I can combine these guys. That's, what am I looking at? Positive 3. So h, when x is x plus 2, is x squared plus x plus 3. Kind of a weird thing. Is everybody okay with that? Algebra stuff. Okay, next. They love these problems on the ACT, so let's do some of these guys. If f of x equals 2 to the x power plus 5, fill out the following table of values. So we are given x values. These, again, are our inputs. So I'm going to input each one of those numbers into my equation. Let's start with 2 to the negative 2 power plus 5. I'm plugging it in for x. Do we remember what happens with negative exponents? Anybody? What does a negative exponent do to my number? Anybody remember? It's been a minute since we've done exponents, right? If I have a negative exponent, that's going to make my number into a fraction. So I can rewrite this as 1 over 2 to the positive second power. So 1 over 2 to the positive second power is like 1/4 plus 5, or 5 1/4. So that's what this guy is right here. Let's do the same thing here. 2 to the negative 1 power plus 5 is like 1 over 2 to the first. 1 over 2 to the first is 1/2. 1/2 plus 5 is 5.5. Let's write it like that, 5.5. And then it gets a little bit easier once we have no more negatives to work with. 2 to the 0th power, anything to the 0th power is 1. So that's a 6. 2 to the first power is 2. 2 plus 5 is 7. 2 to the second power is 4. 4 plus 5 is 9. And then 2 to the third power is 8. 8 plus 5 is 13. We are going to now graph these. Remember, our inputs represent the x values. Our outputs represent the y values. So we're going to plot. Our first point goes at -2, 5 1/4, which is like here-ish. And I'm going to keep going. 5.5, 6, 7, 9. 13 is going to be off my graph somewhere over here. Oh, God. Something like that. Algebra 2 people, do we know what we call this kind of function? What this looks like? Anybody? Anybody remember? We're not an Algebra 2 person. This kind of function is called an exponential. Exponential, I think about the x in the exponent. So that x is up here in the exponent, we call it exponential. Good? Okay, I got 2 more pages of this, my friends. Let's flip it over. These are really the problems they love to do on the ACT. They love to give you a table of values. So I have a table of values here in number 3. The top row is all my x's. Remember, those are my inputs. The bottom row is all the f of x's. Those are like my y values or my outputs. So each one of these problems, I'm either going to be given an input and my answer should be an output, or I'm given an output and my answer should be an input. You should have one of each. In letter A, f of -3, the number inside the parentheses always represents the x value. So all of these guys right here, these first 4, I am given the x value. So if I'm looking at f of -3, I'm going to look at the top row to find that x value when x is -3. My answer should be the one right below it, which is 2. Rocket science. Letter B, I look for where my x value is 20. My answer should be the one right below it. It's 0. C, my x value is 8. Here's my x value is 8. My output is 4. Letter D, f of -1. Do I have f of -1 in here? No, so there's not enough information. Sometimes in your homework, I think, you will get a problem that's like this, but you have a little bit of context. I think it's like average heights. So if you have context to your problem, could you probably figure it out? Like, could you go step by step and figure out, like, what's a third of the way between 0 and -3? Probably. You could probably figure it out. But in this case, I have no context. I have no idea what these numbers are. They probably don't even have a pattern that's discernible. So not enough information. Good? Okay. We're going to flip it around. Now in letters E, F, G, and H, I no longer know what the x value is. It's literally asking me, what is x? What I do know is my f of x value. F of x represents those outputs. So I'm going to look in the outputs row, which is now this bottom row, and I'm going to figure out what is x. Well, if the output is 9, then I look right above. The input was 2. Oops. If I look here, the output is 4. Hey, there's 2 places where my output is 4. So there's 2 possible inputs, 8 or 9. And you can write them both down. When f of x is 0, that output is 0. My input was 20. And then when f of x equals -5, I don't have -5. I'm not going to make a guess. So again, not enough information. Any questions on this? Not doing anything too crazy yet? Okay. Number 4. Let f of x equal 2x minus 3. This is my function right here, right? F of x equals 15. Find x. I have to know whether I'm given an input or an output. If it says f of x equals 15, it's telling me that this entire thing is 15. Think like substitution. If f of x equals 15, then I can replace this f of x with 15. So 15 equals 2x minus 3, and I'm going to solve backwards. Do not plug in for x here. Maybe make yourself a note off to the side. I'm going to make a note. Do not say 2 times 15 minus 3 here. That is bad. We don't want that. We're not given the x value. X is clearly blank here. So instead, I add 3 to both sides, and I divide by 2. Questions? We're going to do the same thing with a graph. So again, my x values are my inputs. My y values are my outputs. We don't have y's in these functions. We have f of x's. So when you see an f of x, we're thinking y. In letter A, I have f of -4. -4 is in that parenthesis. That's telling me that that's the x value. So my answer needs to be a number on the y-axis. I'm going to look at the x-axis. Where is x -4? Right here. I'm going to meet that line to my graph. Go all the way up. Here's where my graph touches x equals -4. My answer should not be on the x-axis. My answer should be all the way over here on the y-axis at 2. We need one of each. If we're given the x, we need to provide the y. If we're given the y, we need to provide the x. Letter B, f of 0. Let's start over. F of 0 is an x value. I'm going to look at where my x value equals 0. That's right here. It touches the graph right at that origin. So my y value should also be 0. F of 3. Here is my x value at 3. Here's where x equals 3. I'm going to go down until I hit that line, right at this point right here. And then I'm going to go over to my y-axis. That's probably like -1.8 or something like that. I don't know, viewer discretion. And then lastly, f of -5. I go all the way over here to the -5 column. It touches the graph right there. Again, our y value up and down is 0. Let me erase my markings. Now we're going to go backwards for E and F. Notice the difference. I am no longer given what the x value is. It says find x. So I'm not starting on the x-axis. I am starting where my output, my y value equals 2. So I'm going to look on my y-axis. Y equals 2 right here. Let's see where it crosses my graph. Hopefully you can see it crosses your graph twice. That means I have 2 x values. The first x value is at -4. The second x value is maybe -0.8 or something like that. I don't know, something like that. Any questions there? Okay, let's erase and do it again. X when f of x equals 0. So I'm looking at where my y value equals 0. That's this whole horizontal line right here. My graph crosses that twice again. Those 2 x values are -5 and 0. Questions? I have one more page, I'm sorry. Flip it over. Hopefully nothing new and crazy here. This last page is factoring. We're just going to review our factoring rules, even though we did that at the beginning of the year too. So, first factoring rule that I'm going to be a little bit more picky about starting now is the zero product property. The zero product property is the basis for factoring. It tells us that we can find solutions using factoring. The zero product property states if I have 2 numbers that multiply together to equal 0, then I can set each of those numbers equal to 0 because either one or the other or even maybe both of those things must be 0. That's the only way we can multiply 2 things together to get 0. What I mean when I say I'm going to get picky about this is that we cannot do factoring unless our equations equal 0. So I am going to be picky that you set all equations equal to 0 before you start factoring, during your factoring, every step should say equal 0. If you lose it, you're going to start losing some notation points. Okay. This is my basic rules for factoring. When we factor, we should find our GCF and factor it out. This is the number one step we forget all the time. If you end up with an answer and your bubbles, your parentheses, have a GCF in them, you forgot to take it out in the first place. So make sure that none of your factors have a GCF in the end either. We're going to use the guess and check method. That's my preferred method. If you do boxes, I don't want to see it. Just don't tell me. And then zero product property. We're also going to see one example really quickly with the difference of two squares. This is one of our special cases. It says if I have something squared minus something squared, I can automatically factor out into that form, a plus b, a minus b. That's what this says in number 1 here. So my first term is x squared. My second term, 16, I can rewrite that as 4 squared. So I have x squared minus 4 squared. That's a difference of two squares. I can rewrite that as x plus 4 and x minus 4. Oops. I don't like that. This should really say equals 0 too, I guess. That's the factored form. Questions on that? Then we zero product property that thing, and we say x plus 4 equals 0, x minus 4 equals 0, x equals negative 4, x equals positive 4. We remember this. Maybe we've seen this in Algebra 1, hopefully. And I know you're going to hate me when I say this, but then we're going to graph this. We're just going to do a quick sketch. We know what anything with a quadratic looks like, right? It's a parabola, a U shape. All of our parabolas, if this first term is positive, should open upwards. So I'm going to really quickly just draw myself a little graph here. My answers, my solutions, this is where my graph crosses the x-axis. So I'm going to put negative 4 and positive 4 on the x-axis. And I'm just going to draw a parabola. Oh, that was terrible. I'm going to draw a parabola through them. What the heck is going on? Get rid of that. Oh my gosh. Clearly this does not want to be my friend today. Beautiful. That's it. Any questions on that? Okay, couple more factoring problems and we're done. Number 2. This is normal factoring. I don't have a difference of two squares. It's not a difference because there's not even a minus sign in the middle there. So I know I'm just going to have to do regular old factoring here. The first step when I factor, always, is to take out a GCF. What's the GCF in this problem? 4 and also an x. I can take out a 4 and an x. So I'm going to divide both of these terms by 4x. I'm not going to lose that 4x, by the way. It's just going to go out in the front. And I'm left with x plus 5 equals 0. Do not forget your equals 0, please. From here, I'm kind of done. I don't have to do any other factoring. I can just set each term equal to 0 and get my answers. Every term that has an x in it gets set equal to 0. So not only should I have the x plus 5 equals 0, but we also can't forget about this 4x equals 0 because it has an x in it. So I have two solutions, negative 5 and 0. And we're going to do a quick graph again. It's going to look something like this. I'm going to put solutions at 0 and at negative 5 and draw my parabola. Everybody happy with that? 2 more. 3. Not a difference of squares. Can I take a GCF out of this? What's my GCF? 3. I can't take an x out of that last term, so I can't do that again. I'm just going to drop this 3 down here and divide everything by 3. So that's x squared minus 2x minus 8. Now I get to factor. Regular old factoring. So starting here, Our basic guess and check method for factoring, I take my first number, which is x squared. I figure out what multiplies to x squared, what can only be x times x, so that narrows it down for me really nicely. And then I find factors of my last term, which is 8. 8's got a couple of factors. 1 times 8, 2 times 4. I'm going to drop my 3 down. That just stays there, hangs out there. I'm going to have 2 bubbles equals 0. First part, really easy. It can only be x and x. The second part, the order doesn't matter here because my x's are both the same, but it does matter which pair of factors we pick. We are trying to add these up to -2. Hopefully, clearly you can tell I need 2 and 4 here. I want a -4, +2. We all remember this. From here, I need to set my factors equal to 0. What I do not need to do, I don't need to set this 3 equal to 0. There's no x in it, so I don't need to worry about that. It's just going to hang out. But I do need to do x plus 2 equals 0 and x minus 4 equals 0. Again, quick sketch. Ooh, hello. Unfreeze. Thank you. At -2, +4, and a parabola. Oh, it would be nice if that actually touched that. That's fine. Okay, one more, I promise. We're almost done. Questions? Last one. Is there a GCF in number 4? No. So I got to do this the hard way. I need to figure out what are the factors of 3x squared. There's only one way to multiply these together to get 3x squared. It's 3x times x. Oops. So that makes my life a little bit easier. Remember, sometimes we're going to have multiple options there. And then there's only one way to get 2. It's 1 times 2. So also makes my life a little bit easier. I'm going to draw bubbles. Set it equal to 0. I know 3x and x have to go in there. And now the order does matter. We can't just put the 1 and the 2 in there willy-nilly. Remember, one secret is that I can never put something in a bubble that would make a GCF, so I could not put a 3 in that bubble. It's not an option, but just imagine it is. I couldn't put a 3 there because that would have a GCF. So what we are figuring out is how do I add up to -5 with these numbers here, the 2 on the inside and the 2 on the outside. Well, obviously I want a big number, so I'm going to put the 2 over here because it's going to multiply with the 3. I'm going to put the 1 over here, and I'm going to double check my work here. This is going to be 1x and 6x, and to get a -5, I want that 6x to be negative and the 1 to be positive. 2 answers. 3x plus 1 equals 0. That's -1/3. And x minus 2 equals 0. That's +2. Quick graph, then I'm done. First solution at -1/3. Oh gosh. Second solution at 2. And a parabola. Any questions?